time because we had that snow day or whatever, right? So we have, you guys, we missed the homework quiz day, so we're going to do that today. Before we do that, though, do you have questions on stuff that you want to talk about before we dive in and get that done? You know, if there's homework questions or just general questions or calculator questions or whatever, we can take a minute here and kind of go over some stuff if you need to, so it doesn't feel like this is just sprung right on you. Yes, Bella. Well, tentatively that's scheduled for Friday. Okay.
Yeah, I've been so like cheered involved. You guys are like people on my lives.
Okay, going once, going twice. Yeah, Ella. 13.2 example. So like using that flow chart. Okay. What if I told you you don't need to do that for the homework quiz right now?
Oh, perfect.
Okay. That's good enough? You don't have to do that for the homework quiz. So I'd be happy to do one, but I feel like maybe now is not the best time with everybody like, do you want a minute to look over some stuff? Would that just be helpful? So it's really limited to like 13.1 is like the homework quiz. You will need to use your calculator to find like maxes and mins and x-intercepts and stuff like that. So let's say at 9:25 we'll do this thing. Take 5 minutes and look over whatever you need to, review your calculator stuff, look at your 13.1 notes or whatever. I have 3 sitting on my desk. You're welcome to borrow one. Presumably they have batteries still. Fingers crossed.
Gotta go for the good old lucky red one here.
Sure. Yeah, so in the power strip there's chargers. You can just plug yours in.
Can I just plug it into my computer for the?
Yeah, why don't you just grab one of the loaners and plug yours in, and then you can just trade out at the end of the class, and you should have a nice charged up calculator.
Right,
does that work for you?
Yeah.
Okay. And Rocco, I think you still have like a missing test from the chapter 8 test is still missing.
I thought I took that.
Yeah, I still zeroed in my computer. If you have it and I passed it back and somehow I just didn't get entered,
Okay.
like show it to me, happily enter a number.
Okay.
If not, I
All right, let me
still
see if
need
I have
you.
it.
Yeah, I still need you to take it if you can't find it.
Okay. All right.
Like next Monday,
Hello.
What's going on, Luce?
Nothing much. What's up with you? Mine says R.
So you're in polar mode.
Oh.
Let's change that to function mode.
Okay, thank you.
And then if you're doing like execute minus X or whatever you had in there,
Yeah.
turn that off. And then some standard.
Oh, thank you.
Sure.
Remember she got me centered? She's like, I did like one joke. She's like, lowest joke I've ever seen.
Every time you
Yeah, I was like, you don't have to do all that. No, I think she's gonna keep Gabby on because she's like, yeah, I know. She's
the rest of the team.
She's like, I had to. She's like, center spot. And she looked right at camera. She's like, center spot. She's like, flip to the next page. Yeah, trying to be like, Kat, like, waited on the cheap mat.
I'll be there tonight.
Is Michaela?
He said he never texted you.
Yeah. Oh, you have to do second. Oh, minimum. I've stuck. Yeah, this was the first time I learned ours. What did I like? What's it called? When we were doing like math times, and this first time we fell to my knees. And then was like, come on, let's do it. I was like, I don't know. Yeah, we did.
So we're gonna finish up chapter 13 today. So remember what we've been doing is we start off, we had the question of like, how do we factor or solve? Come on, you stupid thing. A polynomial equation. Really, this was kind of the same question. And we said, okay, well, we can build out this factoring flowchart, but this is still kind of incomplete, right? Like, where if our trinomial wasn't in the quadratic form, there's nothing we could do. Or if our four-term polynomial couldn't be factored by grouping, there's nothing we could do. Or if it had more than 5 terms, there wasn't anything we could do. And we've been trying to fill in, okay, what if we land in one of these 3 situations? Like, what is there something we can do? And that's what we've been building out here throughout chapter 13, at least in sections like 2 and 3. And we're going to kind of complete as far as we're going to go here into section 4. So through section 13.3, we've seen how to solve for the real zeros for a polynomial. So like a question like this. So what we'd want to start with is our possible rational zeros. And we know those are going to be the factors of the constant term divided by the factors of the leading coefficient. So my factors of 30 are all of these guys, yuckarooskies. And then my factors of 6 are all of these guys. Woof, that's a lot of stuff to have to grind through. So to help narrow that down, we're going to look at the graph. So I'm just going to go ahead and type in my function. So if I look at my graph, it looks like I have one x-intercept here at -6, another one between 0 and -1, and another one between 2 and 3. Everybody's okay there? Maybe let's write those as inequalities so they don't look like points, huh? Now, x equals -6, that's easy to handle, but if it's something between -1 and 0, well, that could be like -1/2 or -1/3 or -1/6, or like 2/3 or 5/6. So there's like a bunch of possibilities there, right? And between 2 and 3, what could we have there? You could have 5/2. We could have 15/6. There's probably something else that I'm missing. Oh, yeah, I guess those are the only two. Anyway, so, and the other thing I'd want to do when looking at my graph here is to just kind of look for my bend, bounces, and straights to give me an idea of how many times this solution might be occurring. If I look at each one of these x-intercepts, they're passing straight through, so they're all straights, which is helpful for me when I get ready to do my polynomial or my division, to know how many times I'm going to divide with that number. If I look at all my choices here, the only one I think I know for sure is this x equals -6. So that's the one I'm going to choose to use. So I'm going to go ahead and set up my synthetic division. Oh my gosh, 6 times 13 is not 39. Ay, ay, ay. 78 is more like it. There we go. So what this is going to tell me is that my polynomial factors to x plus 6 times 6x squared minus 13x minus 5. Where those coefficients are the coefficients for that polynomial, the other piece of my factor. So now I could do one of two things. I could continue factoring, or continue my synthetic division. But the problem is that the number I'd want to put on the outside is kind of a guess, right? I've narrowed down the amount of things to choose from, but it's still kind of a guess. I hate guessing. Instead, what I'm going to do is I'm going to just try to factor this thing. So to factor this, I need to find the two numbers that multiply to give me the leading coefficient times the constant term, and then add to give me that middle term. So multiplies to give me negative 30 and adds to give me negative 13. That's going to be negative 15 and 2. So those two numbers tell me how to break up that middle term. So negative 13x is going to turn into negative 15x plus 2x. I'll make my two groups. From the first group, I can take out a greatest common factor of 3. From the second group, there's nothing to take out, so I'll just take a 1 out, right? There's nothing in common between 2x and 5 other than 1. Oops, 2x squared. So now if I look, there's a 2x in common between each term. So if I factor that out, I'm left with 3x plus 1. So we have x plus 6 times 2x minus 5 times 3x plus 1. That's the factored form for my polynomial. Depending on what the question asked, that could be the answer if they just asked me to factor. If they asked me to solve, I then take each of these factors and set them equal to 0. And I just have the one additional step here. So I get negative 6, 5 halves, and negative 1/3. Hi.
Just double checking for a call. Joey Riley's answer.
Right, Joey's not here, right? Yeah, he's not here.
Thank you, sir.
Yep. Okay, so that's what we've been doing, right? We're going to add a couple more details to help streamline this process a little bit more. So the first thing we're going to add is called the fundamental theorem of algebra. As you might have guessed, this is pretty important with a name like fundamental theorem. So it says that all polynomial equations have solutions, and that the number of solutions is going to be the same as the degree as long as we're counting real solutions, imaginary solutions, and multiplicities. Okay? So the number of x-intercepts may be less than the degree, but the total number of solutions, as long as we're counting everything, is going to be the same as the degree. Everybody's okay with that? Additionally, we're going to have the irrational conjugates theorem. and the complex conjugates theorem. So the irrational conjugates theorem says a polynomial with rational coefficients we should say if a polynomial with rational coefficients has the 0 a plus square root b, then it also has the 0 a minus square root b so as long as b is not a perfect square. So for example, if I have the solution 1 minus square root of 2, it means I'm also going to have the solution 1 plus square root of 2. Or if I have the solution negative square root 5, it means I'm also going to have the solution positive square root 5. Everybody's okay there? That those are coming in conjugate pairs. The complex conjugates theorem says basically the same thing. It says if a polynomial with real coefficients has a 0 of the form a plus bi, then it also is going to have the 0 a minus bi. So for example, if I have 1 minus 2i as a solution, then I'm also going to have 1 plus 2i. Or if I have 6i as a solution, I'm also going to have negative 6i as a solution. Everybody's okay there? So let's say all right, so let's say we're asked to write the polynomial of lowest degree with real coefficients that has zeros 1, negative 3, and 1 plus I root 2. So to do this, I know that these guys have to be solutions. And because of the complex conjugates theorem, this 0 also needs to have its conjugate pair with it, right? Everybody's okay so far? What I'm going to do now is get these equations so that they're equal to 0. So I'll subtract 1 from both sides. I'll add 3 to both sides. I'll subtract 1 plus I root 2 from both sides. And then subtract 1 minus I root 2 from both sides. Everybody's okay there? And just like before, if I multiply these all together, since they are all equal to 0, when I multiply them together, they're all still going to equal 0. And now all I'm left to do is FOIL this out, right? Now, to FOIL this out, what I'm going to do is I'm going to multiply these guys together. And then I'm going to multiply these guys together. The green ones, I'm going to do that just quickly in my head. The blue ones, I'm going to write out this a little bit slowly so you guys can see what I'm doing, because there's actually kind of 2 FOILs that are going to need to happen in here. So I'm going to multiply just like I normally would with any kind of FOIL, but I'm going to treat these inner pieces that are in parentheses as like one thing. Is everybody okay with how I FOILed that out? Notice I treated those inner pieces that are in parentheses, the 1 plus I root 2 and the 1 minus I root 2, is just like one thing when I did my FOILing. Okay, so now I'm going to FOIL each of these. What I have to be careful though is that I'm taking the negative sign with the x when I'm doing that FOILing, because the negative sign's in front of it. So I have minus x plus I root 2x. Then I have minus x plus I root 2x. And then notice these are just a difference of 2 squares, right? So that's nice. So I can just use my difference of 2 squares factoring pattern to FOIL that out. You could FOIL it by hand if you wanted to, but I'm just going to use that a plus b times a minus b is a squared minus b squared to FOIL that piece. Now if I look when I combine my like terms, oops, look, I even goofed it up there. That's supposed to be a negative sign. I have a plus I root 2x and a minus I root 2x. Those cancel each other out. And when I square this thing, I'm going to have I squared times root 2 squared. Well, root 2 squared is just 2. And what's I squared the same as? Who remembers what I squared is? Negative 1, yeah. So that just all is going to become negative 2 there. So x squared plus 2x minus 3, and then x squared. I have a minus x, another minus x, that's minus 2x, a plus 1, and then a minus 2, so that's a minus 1. And now I just need to FOIL these two things out. So that's going to be x to the 4th minus 2x cubed minus x squared plus 2x cubed minus 4x squared plus 2x. So again, I'm just doing like whoop, 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 and then whoop, 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 and then we'll do whoop, whoop, whoop. So minus 3x squared plus 6x plus 3. And if we combine all these like terms together, those guys canceled out. Negative 1x squared minus 4x squared, that's negative 5x squared. Oops, and then I have another minus 3, so it's minus 8x squared. And then I have a 2x, a 6x, that's 8x, and then plus 3. So that should be my final answer. Oh no, I made a goof. It's a little goof, but it's still a goof. So that's really like a plus, right? Because I have minus and negative. So this should be plus 3. So that's going to be a plus 3x squared there. So that should be minus 5. And then it's going to be a plus 6x there. It's going to be like 12. And then that's going to be a minus 9 there. So something like that. Anyway. Ugh, can't add at all. That's a minus 4. Sorry. Okay. And the other thing that we can now do is now be able to find all the zeros for a polynomial. So the fundamental theorem of algebra tells me that I have 3 solutions. My possible rational zeros are going to be the factors of the constant term divided by the factors of the leading coefficient. I'm going to then look at my graph and look for x-intercepts. Does this all look kind of familiar? This is all stuff you guys should have done last year in Algebra 2 classroom, right? So I do that, hit graph. So I see a solution here at -4. And that looked like a straight, right? The graph was just passing straight through. So that's only one solution. Where are the other 2 going to be? So the other 2 are going to be imaginary. The only way we're going to find those is using the quadratic formula. So we'll start with our polynomial division. So that tells me then this factors to x squared, or x plus 4, and then x squared plus 9. Again, remember, remainder constant x squared. And if I set this equal to 0, I get -4 as a solution. And then x squared plus 9, I could use the quadratic formula on that, or what's probably easier is to just solve this directly, right? Since there's no regular x term, it's just x squared. I can do that. So remember, when we square root a negative, you get the I on there, and the square root of 9 is just 3, so I'm left with 3i, and the plus or minus from doing the square root to both sides. Let's do another. Okay, but this is like the final twist here, is where we start throwing in imaginary solutions in here too. Ooh. So find all the zeros for the polynomial. So again, start fundamental theorem of algebra tells me I have 4 solutions. My possible rational zeros are going to be the factors of 35 divided by the factors of 8. I'm then going to go to my graph and take a look at the picture and see if I can narrow that list down. Oops. So plus. Okay. All right, so I see 2 solutions here. Ruh-roh, Raggy. Did I type something in wrong? 8x to the 4th plus 27 x squared plus 62x minus 35. Okay, I typed that in, right? Nobody saw a typo? This is a broken example. Sweet. Just create a new one because this one is apparently broken. Okay. So I'm just going to fix this on the fly here. So that minimally has to change, still 4 solutions, still the same possible rational zeros. Okay. hate this. I take this back. I don't want to do it this way. Let me try one more. Maybe the other one was okay. It just stinked. All right, whatever. Ugh, guys, I'm sorry. I think the old one was okay. All right, so all the action is happening here. I'm going to zoom in a little bit to get a bit better of a look. So it all looks like it's happening between -2 and 1. So if I look, this one is a little less than -1, and that looks like about 1/2, right? Everybody agree? So I see 1/2. That looks pretty clear to me. But the other one, maybe that's -5/4, or maybe that's like negative, what else could I have there? I guess it's probably that, but I'm gonna, yeah, I think it's gotta be, right? Nothing else is close to -1. So I'm gonna go ahead and start my synthetic division. I'm gonna use 1/2 because, boy, that looks a lot easier to deal with than the -5/4, but I think I'm going to be stuck doing that either way. Oh, they're both straights also. So that's 2 solutions. So I'm also going to have 2 imaginary at the end. So that worked. So we're going to have x minus 1/2 times 8x squared, nope, cubed, minus 22x plus squared, 16x plus 70. But that's cubic. I can look real quick and see pretty quickly that there's that's not going to factor by grouping. So got to keep going. So now I have to do that -5/4. So again, bring that down. That's going to be -16. No, that's not right. Sorry, -10. And then 40. And then 14 times 7, -70. So that works. So there's that. I notice in this trinomial at the end, there's a greatest common factor of 8. Now the 8, what I'm going to do with that, I guess it doesn't really matter. If I was going to try to factor this, though, I would think about that 8 as like 2 times 4 and multiply the 2 into that one and the 4 into that one. So there's my factored form with integer coefficients. Don't need to do that though. If I set this equal to 0 and say we want to solve it, there's the solutions 1/2 and -5/4, so you knew that already. To solve this guy though, that doesn't factor, does it? Are there two things that multiply to give me 7 and to give me -4? No! What do I do instead? Quadratic formula. When I'm finding the imaginaries, I'm really never going to be able to factor these. I know I'm always going to have to either use the quadratic formula or have to solve directly. So that's 16 minus 28. Now, so the square root of -12, well, I get an I for the negative. And then 12 is 4 times 3, right? So the square root of 4 is just 2. So I have 2i root 3. And then I'm going to think about this as two separate fractions with that common denominator of 2, and then reduce. So I got 1, 2, and then because of the plus or minus, that's 3 and 4 solutions. What do you guys think? Some of these problems are long. It's okay. I wouldn't ask you to do very many on a quiz or a test setting. I would try as much as possible when I write the test to give you questions that are like, just do this step of the problem. Here, you know, like on a problem like this, I might give you the start and give you this stuff and ask you to go from there. Or I might just ask you, you know, like give you this thing and ask you to do this. You know, where I'm going to try to chunk these problems up so that you kind of get lost in the midst of a long process. It's not lights out for you, that I'm just going to ask you to do like parts of the problem and then ask you to do the whole thing kind of thing. You know what I mean? Which I think is probably more fair, and they're all separate problems where they're not based on the result of a previous one. So like if you screw up a little part in the beginning, it doesn't carry through and make it a whole mess out of the thing. Now, I will expect you to be able to do the whole process by yourself like 1 or 2 times, but I won't have like a bunch of these. I would have the steps in there, like write out, you know, find the possible rational zeros for this, find the number of solutions to this, like analyze this graph and identify like, you know, this thing or that thing or the other. You know what I'm saying? I think all that kind of stuff is fair. But that's going to wrap up chapter 13. So I think what's left for you guys is, what is it? It's going to be, what did we assign last time? Up through 43, right? I think we're probably 44 to 53 now. Let's go back and look at the last one. Oh, did I not write it down in the paper? Oh, I did. 16 to 35. Oh! We got to do 36 to 53 then. Oops, I erased the wrong one. So that should be the homework.